what does a dot product operation look like? So if I have A dot B, what am I doing? I'm taking the sum from I equals 1 to n of AI BI. So this is something like, I mean, in some way, this is like a filter. So if I have S0 of k involved with h of k, and I evaluate that at NB. So you remember it, when we were in chapter 3, we re-represented this. So this is equal to the sum from I equals 1 to NB of S0k times h of NB minus k. And remember, it makes no difference if I rearrange these indices. So what I can do is I can replace h prime of k is equal to h of NB minus k. So that's just all h prime is a permutation of h, and I can go back and forth between them. So this would then be equal to the sum from I equals 1 to NB, S0k, h prime of k. So in other words, if I think of S0h as both vectors, what I end up with is S0 dot h. So what's the idea up here? If I have an orthonormal basis, if I have two signals, and I want to and they're not linearly dependent, and I want to represent them in some basis, then what I'm going to do is I'm going to take each orthonormal basis vector, and I'm going to match a filter to that. So this is just we're gonna say lots about this, but this is where we're going. This is why I'm talking about this, is because these orthonormal basis vectors give you the match filters in each dimension. So in other words, if you have, let's say, a 5-dimensional space where there's 5 independent vectors, then you would have 5 match filters, each matched to the orthonormal basis vector. And basically what the match filter would be doing in the noise-free case is pulling off the components in each orthonormal direction. So if you think about it, this is implicitly what we've been doing so far, except that the match filters have not been orthonormal. They've generally, so in other words, polar NRZ, for example, has an S0 that looks like this, an amplitude of 1 up to NB. So the norm of this would have been NB, I think. No, the square root of NB. So the only difference between what we've been doing before in one dimension and this type of match filtering is that here we're orthonormalizing first. But that fundamentally makes no difference because that's just multiplying by a constant. But like I said, we're going to say a lot more about that. But I just wanted to let you know sort of where we were going with this.